My name is Ismail Sheikh, and we are showcasing our first project. We have two projects here. First one is that ultrasonic smart radar system, and second one is our firefighting robot. So, starting with this is ultrasonic smart radar system. This is our first project. So, ultrasonic smart radar system is a microcontroller-based radar system which uses ultrasonic sensors to detect objects. Now, it is powered by Arduino Uno, and it is capable to detect objects near 20 centimeters, and it can rotate up to 165 degrees. So it can in generally scan 125 degrees and 20 centimeters. And because this is so small, because it is just a demonstration purpose only. So coming to the technical specification, the components we are using in this system, as you can see, we have used Arduino Uno, we have used HCSRO for ultrasonic sensor, and we have used SG09 servo motor, and we have used jumper wires to connect them, and we also have used a mini breadboard connector, and we are monitoring it, and we are actually controlling it with the Windows PC right here. Moving on to the required software, the software we are using here is Arduino IDE, and radar displaying app that we are using is the Processing 4.2. Both of them are compatible with the Windows operating system from the Windows 7 to Windows 11, the latest generation of the Windows. So, coming to the circuit diagram, ultrasonic sensor and micro servo motors are used in this system, and we have connected them with the help of the breadboard connection, with the breadboard connector. As you can see right here, the ultrasonic sensor, the cables are going to the VCC is going directly to the breadboard connection, the ground is going directly to the breadboard connection, both the servo motors connection are going to the breadboard connection, and after that the echo and the trigger plug is also going to the breadboard connection, and from there we are coming to the Arduino connection, the pin 11 and 10, and the servo motors signal connection is going to the pin number 12. And the point to be noted, the power it is receiving is directly from the Arduino board, and the Arduino board is receiving power directly from our laptop. So let's talk about HCSRO for ultrasonic sensor and the mechanism, the way it is detecting the objects. So as you can see right here, like in ultrasonic sensor is sends very high frequency sound, and the high frequency sound is sending through its speakers, and it receives echo signals through its microphones, the microphones inside. So it is like that, imagine that this is an object and this is the ultrasonic sensor. So when the ultrasonic sensor is sending the sound, it is going here and it is echoing, and when it is coming, the sensor is receiving, and that's how it can calculate that how far the object is and the availability of that object. So moving on to the micro servo motor. Our micro servo motor is SG90 micro servo motor, which can rotate clockwise and counterclockwise up to 180 degrees. But we are programming this for this particular thing 165 degree. We have set to 165 degree, and it is attached to the, and our ultrasonic sensor is attached to the tip of our servo motor. We have just glued them together, so it stays like this. As you can see in our sensor, it is rotating for 165 degrees. So let's talk about the working principle right here. So when the radar senses any object near it, so when it senses, so what it does, it actually gets the signal, and the signal goes to the Arduino board, and then from the Arduino board the signal is going to the laptop, and in the laptop the software is actually processing it. The laptop actually processing it and giving us the signal like you are seeing here, like this, the signal when our sensor is moving, our radar is moving, and it is scanning in the monitor. We will notice the object, the availability of the object and the distance of the object. Okay, so for the social impact, I would like to call my team member Mitu to talk more about this. Mitu.
From here, we will discuss about social impact of the radar system. So, low visibility conditions causes increased speed variance, which increase crash risks. Each year, over 38,700 vehicle crashes occur in fog. Over 600 people are killed, and more than 60,300 people are injured in these crashes annually. Operating a vehicle in show high winds or on icy roads can be problematic, but rain is responsible for the most weather-related accidents. A smart radar system can easily detect nearby objects and can alert the driver, therefore accident can be reduced. So the future implementation of the radar system, powerful ultrasonic radar system can be used in the field of automation. It can be used in every kind of vehicle to ensure safer navigation. This system can be a built-in system, or it can be used as an accessory device. So the conclusion part of this project, a lab-scale radar system was designed and implemented using an Arduino, a servo motor, and an ultrasonic sensor. So here the demonstration of our project.
practically দেখা demonstration দেখানো কথা
जी सर practically
run this.
So, excuse me sir, may I have your attention please? So, as you can see right here in our laptop, this device, this our radar is scanning. Now, right now this is my hand. I am placing my hand right here. You can see that it is receiving the signals. It is receiving in the right direction. Imagine this is an object, and this is our hand. This is this is an object. So it is detecting my object that this is that far away, and after that it is scanning the firefighting robot right here. So it is also showing the
left side
it is scanning this pen. When I am placing my pen right here, you can see that it is scanning the pen right there. It is showing the signal. Now this is the paper. If I put the paper right here or right here, as you can see, sir, as you can see, it is also detecting our paper. So it has the ability to detect up to 20 centimeters, and it is rotating clockwise and counterclockwise up to 165 degrees.
Today our presentation topic is about our project, and we have made line follower robot. Here is a picture of our team. We are Volta 1.1. Here is our instructor name, Sunjida, lecturer, University of Scholars. The line following robot. Here is the presentation outline. Here we can talk about what is LFR or line follower robot, what type of hardware is used, what type of software we used here, circuit diagram, block diagram, truth table, flow chart, extra features, what we have input in this project, working principle, real life uses, and some drawbacks of this project. So first of all, what is LFR or what is line following robot? Actually, a line following robot is a robot which can follow a line. The line may be white or black line. It actually depends. What type of line we are using. There is some manual what we have used here, hardware part, Arduino Uno. We use Arduino Uno as a microcontroller. We use IR sensors, 3 IR sensor actually, L298N motor driver, DC gear motors, PVC pipe as chassis. We do not buy chassis from market. We just made up chassis with PVC pipe, jumper wires, wheels, and battery.
Assalamualaikum. Hello everyone. I am Mohan Professor, Batch 11, Department of Technology. Thank you so much, my presentation program. After question here, now I am going to show another softwares. Arduino IDE used to program to microcontroller for 3D design and circuit diagram online simulation. We use tinkerbell.com website, and this model is designed by ourselves. We do from anywhere for design and purpose. Our edits and in short video editing. Congenial motor drivers and 5-volt power supply from L258 motor driver and goes to 3 IR sensor. Each sensor output goes to Arduino Pino 30. And
here is a block diagram for our project. Actually, we have given power supply to Arduino board and IR sensors. Then the power goes to the motor driver. Another power supply goes to motor driver, and from motor driver we are controlling the left and right motors of our LFR. Here is a truth table. You can see here RS means right sensor, LS it means left sensor, FS it means front sensor, RM means right motor, and LM means left motor. So if you see here, when RS and LS is 1 and FS is 0, our motor gets 1 and 1. Actually, our motor is getting high signal from the Arduino. As usual, we can see here is 8 different cases for our project, and 8 different cases. The comment will be different for each and every truth table. So here is a flow chart. Actually, how our Arduino or our project is working. We are showing there. First of all, our Arduino is our sensor take a sense if the front sensor get any line. If the result is yes, then two motor rotate at one direction and goes to forward. And if the result is no, then sensor sense is if the left sensor or right sensor is in the line. As the same, there is the output for each and every sensor and their sensors. So So here is a working principle for our LFR or line follower robot. Actually, before knowing the working principle of our robot, we have to know the working principle of IR sensor, how the IR sensor actually works. Actually, a IR sensor is a sensor which can show infrared light, and if the light reflected from anywhere and there is a receiver, IR receiver, which can receive the infrared red light. If the sensor get any infrared light get back, the sensor give a low voltage or low signal to Arduino Uno. And on the opposite, if it get did not get any signal from sources, then it will show high voltage or high signal to Arduino. And that's how if there is detect any line, the sensor sense that there is a high voltage or high signal, and Arduino process this, and finally we have an outcome for right, left, forward, and reverse movement. So here is the extra feature what we have import in this project. Actually, a typical line follower robot can only follow one direction of line. It cannot process too many lines or junction of lines. So we have tried to add some features so that our line follower robot can solve many types of problems. Actually, we are solving 8 different cases. You can see here is a track we designed it. If our robot starts from here, it's in this point, it shows there is a line in right and front. What will it do? So the line follower robot, our main focus is if our front sensor is in line, so the line follower will go forward. So in this situation, it will go forward. As the same, when it get a sense from left and front, it always go to the front. And in this junction, there is the same case. In this junction, there is a 90-degree sharp angle or sharp turn, and there is a in this scenario, our 3 sensor, right sensor get line, second and left sensor will also found a line, but the front sensor did not find any line. So what will our robot actually do? So it always, if the robot sense right and left line, it always take a right turn, and then it goes to this line. And here there is another point where is a sharp turn. It will also take a sharp turn, and there is also a 90-degree sharp turn, and the robot actually goes like this. Now we'll talk about the real life uses of LFR or line follower robot. Actually, in manufacturer companies like bigger manufacturer company, airports, and other delivery purposes, we can use line follower robot. And the industrial line follower robot actually solve too many types of problems. But if there is a problem, if our industry have too many line followers robot, and if we draw for every line follower robot and every different track, the space will be increased. And so if we input our features in the line follower robot, then we can run a robot in a single line, so many robot in a single line. So some drawbacks of our line follower robot right now, but we are trying to solve it. Actually, in this present scenario, our line follower robot speed is over excess, and we cannot control it right now. But we are trying to control the speed, and the sensor accuracy is low. For that, we sharp turn and 90-degree angles did not found properly. We are trying to improve this problem. I hope we will, in the next presentation, we will solve this problem. Thanks to all. We try our best, but we did not. But I think we will do the best, and we will improve this project and compete many competition with this line follower robot. Excuse me, we have a video demonstration here.
Here is the Arduino based firefighting robot. We will discuss about this project. I am Mahfuzur Rahman Mitul and my team members Ismail Sheikh Noyon, Rajan Shikdar and Amirul Islam was absent. So the presentation outline of this project, system overview, hardware and software, working concept, circuit diagram, advantage of proposed system, future enhancement, conclusion, reference, and the other hand video demonstration. So system overview. This prototype designed for reduce human effort, reliable and economical. It reduces the time delay in reaching fire affected area. Materials and components, Arduino Uno for input and output feedback, sensor and system circuits. Our power consumption for this prototype, operating voltage 5 to 35 volt, logic voltage 4.5 to 7 volt and maximum current 2 ampere per channel. So the hardware and software. Here you can see the hardware Arduino Uno, fire sensor, servo motor and the motor driver L293D mini DC submarine pump, small breadboard and 4-wheeler robot chassis and 4 DC motor, small can connected nodes, and the software is Arduino IDE. So now my friend Ismail Sheikh Noyon discuss about the working concept of this project.
Thank you, Mitul, for your introduction part. Now, I would like to discuss about the working concept of our firefighting robot. Now, starting with the Arduino Uno controller, we are seeing right here, the Arduino Uno microcontroller is the brain of this system, because it is controlling every single sensor right here. It is connected with those sensors directly and indirectly through the breadboard connection or directly from the Arduino board, and it is receiving power from the batteries inside. Now, it has a bottle which contains water, and the water comes through this nozzle. Right, you can see right here through the vacuum pump. So we are going to put the vacuum pump into the water jar, and from that water bottle the water is coming through this nozzle, and this nozzle will be connected to the servo motor which actually rotates. So the water that coming through the servo motor, and because coming through the pipe, and because it is attached to the servo motor, the thing that is happening here, that the servo motor is rotating and the pipe is also rotating with the servo motor, so the water is spreading in an angle, not directly in an angle. So the water is spreading in an angle, so it is reaching the fire accurately and precisely. So moving on to the working concept of the firefighting the fire sensor right here. Our fire sensor contains an IR receiver. It is actually a photodiode, IR receiver or photodiode. What is happening here? We know fire actually emits infrared light. Infrared light fire actually emits. So this sensor right here, you can see this sensor actually senses the infrared light coming from the fire, and it can sense, it has the OP-AMP to check the change in voltage across the IR receiver. It has it can detect the output pin. It is 5 volts, and after that, when there is no fire, it will give 0 volt actually. And we are placing 3 sensors right here, as you can see. This is the forward sensor, and this is the and the left and the right sensor right here, as you can see. So now I'm going to talk about the working concept of this firefighting robot, the way it controls itself automatically. Now, suppose that if there was fire, fire anywhere, these sensors will detect the fire and the data will go to the Arduino controller. From the Arduino controller, the data will it will calculate the data and it will give signal to our motor driver, and also it will give signal to the servo motors and also to the pump. So what is happening right here, the motor driver we are using is L392D. L293D module. So this module right here controls the DC motors. The DC motors inside in the chassis, the DC motors that you can see right here, and the DC motors actually controls the wheels. And when it detects the fire, it will go near to the fire, and after that it will stop there, and from right there it will the servo motors will start, and the pump right there, the pump will also start. So it will start when it goes near to the fire, and after that it will actually spread the water into the fire. Now, if may I have your attention to the circuit diagram right here. Like you can see, there are 3 fire sensors. So the connection we have give a series connection right here, and also from the ground there is a series ground. The series ground connection is going to the Arduino. The series VCC connection is also going to the Arduino, and the signal connection right here, you can see it is also going to the Arduino controller. And the servo connection right here, servo connection is also in series with the fire sensors, and also it is going to the Arduino pins. And also you can see, you can notice right here the motor driver's connection. The motor driver is also connected through the Arduino connection, and it is powered by 12 volts. So the power it is actually coming from the 12 volt connector. And also, may I have your attention to this diagram right here. This is the diagram for the water jar, the water bottle which is attached with the robot. As you can see right here, there is a water pump, there is a water reservoir, and there is these Arduino connections. So there is a relay right here. So the relay connection is relay is getting power from the battery, and relay one of the relay connection is going to the water pump, and the connection, the signal which is receiving, which the relay is receiving is from the Arduino controller, and there is a push button which actually we are this is the demonstration purpose of this system. So the push button actually signaling the system to switch the motors and the servo motors. But we are doing this automatically through our Arduino controller, so this switch button is not necessary. Now, moving to the way the pump is actually working. So we have fixed the servo motor to the bottom of the container using glue, and have fixed the servo motor with chassis using nuts and bolts. So we are actually putting our everything, like you can see here with the chassis. This is the chassis. We are actually putting everything with glue or nuts and bolts to attach them with the chassis. To talk about the advancement of this proposed system and the future enhancement of this device, I would like to call our team member Rajan to come and tell you more about this project.
Okay, now we will talk about the advantages of proposed system. The robot will be used at places where it is dangerous for humans. Capability of sensing accurately will increase flexibility, reduce human effort, and reliable and economical. It reduces the time delay in reaching fire affected area It reduces the errors and the limitations that are faced by human firefighters. Sensors have long time and less cost. The future enhancement of this proposed prototype, some of interfacing applications which can be made are controlling home applications, robotics, movements, speech assisted technologies, and etc. By making it GPS enabled, robot can be controlled from remote station also. It can be further expanded with voice interactive system facility. Now the conclusion of this robot, for using this robot, we can sense fire accurately and it has a small body shape that it can easily go in any type of fire affected area. So here are some references, Wikipedia, Circuit Digest, ResearchGate, and Arduino, etc.
Assalamualaikum. Hello everybody. A very good morning to you all. We will start presenting our project. Now let me introduce you to our group members. MD Bodrul Islam, MD Sakir Hossain, MD Arafat, and me, Shahar Islam Rokon, and MD Mehdi Hasan. Our post-instructor, Shahzada Mushkinova ma'am. Let's begin. We will see the outline of obstacles avoidance robot. There are introduction, working principle, hardware requirement, software requirement, Arduino UNO features, ultrasonic sensor, block diagram, circuit diagram, working attitude, applications, conclusions, and reference. Now I will describe the introduction of obstacle avoidance robot. Robotics introduction. Robotics is a part of today's communication. In today's world, robotics is fast growing and interesting field. With the help of robotics, we can design machines to make the life easier. An obstacle avoiding robot is an intelligent device which can automatically sense obstacles in its path and can avoid them. Now,
Thank you. Now I describe the use of obstacle avoidance robot. The obstacle avoidance robot use Arduino sensor, use ultrasonic sensor for its movement. A microcontroller of 8051 family is used to receive
the desired operation. The motors are connected through the motor driver IC to the microcontroller. The ultrasonic sensor is attached on the front of the robot. Next, whenever the robot is going on the desired path, the ultrasonic sensor transmits the ultrasonic waves continuously from its sensor head. Whenever an obstacle comes ahead of it, the ultrasonic waves are reflected from the object, and that information is passed to the microcontroller. The microcontroller controls the motor left, right, back, front based on ultrasonic signals. To control the speed of each motor, pulse width modulation is used. Now we will use some hardware. Here is the hardware requirements on Arduino Uno, on Arduino motor drive shield. Number 3, 4 gear motor, 1 servo motor, on ultrasonic sensor, 9-volt battery with holder, and some jumper wire, on set of chassis, and 4 wheels. Here is the software requirement. Arduino IDE, programming language used C++. Next, we describe the Arduino Uno features. There are a microcontroller board based on the ATmega 328P, 14 digital input-output pins, 6 analog pins, 16 MHz quartz crystal, a power jack connected it a computer with a USB cable, or power it with a AC to DC adapter or battery to get started. Software requirement, we have used software requirement is for coding in Arduino chip. We have used Arduino IDE and some header file. Here is the servo.h for servo motor, and fmotor.h for DC motor, and newping.h for ultrasonic sensor movement. Some following function used for for coding: setup function, look right, look left, read ping, move stop, move forward, move backward, turn right, and turn left. There are so many functions used for obstacle avoiding robot for movement. Now next describe the ultrasonic sensor. Our team member Bodhu.
Thank you, Sabir, for giving me opportunity. Here is the ultrasonic sensor ACSR04 working principle. Ultrasonic sensor has 4 pin, 1 VCC, trigger pin, echo pin, and ground. Here is the object and ultrasonic sensor. One signal transmit distance, object, and reflect signal in receiver. Here is the one, here is the another one. First transfer wave, object, and reflect from receiver in ultrasonic sensor. Here is the hardware block diagram. One power supply, Arduino Uno, Arduino motor driver shield connect with Arduino Uno, 4 gear motor, 1 servo motor, and 1 ultrasonic sensor. Here is the circuit diagram on our project. First, Arduino Uno, motor driver shield connected on Arduino Uno, 4 gear motor connected motor driver shield for 1 to 4 channel, ultrasonic sensor connected motor driver shield. Motor driver shield Arduino Uno pin number VCC pins, motor Arduino pin analog pin 0, VCC 5 volt, trigger pin analog pin 0, echo pin analog pin 1, and ground pin ground. Servo motor connected with servo pin. Here is our working A to Z in some picture. Future work. The robot is one basic level with the advancement in robotic. It can be modified. It can be used accident avoiding car, auto parking assistant, can be used in household work, vacuum cleaner, can be used mining vehicle that uses obstacle detection, especially used in military operation. Conclusion. This project provides an obstacle avoiding robot that detects obstacle coming in the path, avoid its moving another direction. The robot is built an Arduino Uno microprocessor that informed to various parts, one ultrasonic sensor, four gear motor, one servo motor rotating the sensor. The robot able to move by using four gear motor. It is preferably used avoiding the obstacle coming in the path. Here is the reference and thank you all.
ভিডিও ডেমো
তাহলে তুমি 90 কেন 90 কমে ঘোরাতে পারো না
আর কি বলছো বুঝতে পারছো?
এখানে একটা অবস্ট্রাকশন এখানে একটা অবস্ট্রাকশন তোমার গাড়িটা এখানে আসলো হ্যাঁ তো 90 ডিগ্রি ঘুরলে তো একদম গাড়ির মাথা এখানে ছিল মাথা এখানে চলে আসে তখন তো এমনি অ্যাভয়েড করতে হবে বাট এটা ঘুরে এই পজিশনে যখন আসবে তখন কিন্তু অবস্ট্রাকশন নাই সো এই অ্যাঙ্গেলটা কিন্তু 90 ডিগ্রি না ঠিক আছে তো তুমি মিনিমাইজ করতে পারবে না এটা মিনিমাইজ করতে পারবে যে 90 ডিগ্রি না দিয়ে তোমার এই যে ডিসটেন্সগুলো যদি তুমি ধরো যে কোন সাইডে ঘুরবে এটা আগে ফার্স্টে হ্যাঁ তারপরে হচ্ছে কি এই যে বারটা যে বারটা অ্যাভয়েড করতে সে পাস করতে পারবে ঠিক আছে ওই বার কত অ্যাঙ্গেলে আছে ওটা মেজার করতে পারলে তোমার রোবটকে তুমি এই দিকেও পাস করাতে পারবে তাই না সো এই জিনিসটা বাট ভালো হয়েছে ফার্স্ট টাইম যেহেতু থ্যাংক ইউ
ঠিক আছে আপনাদের আমি আমার খুব ভালো লাগলো তোমাদের এই প্রেজেন্টেশন দেখে অ্যাকচুয়ালি আমাদের ইউনিভার্সাল স্কলারশিপ টেকনোলজি ডিপার্টমেন্টের যে যাত্রা এখন মানে নবযাত্রা শুরু হয়েছে এটা আমরা খুবই আনন্দিত কারণ আমাদের এই ত্রিপুরা ডিপার্টমেন্ট আমরা তো যখন বারটা থেকে যখন আমাদের যাত্রা ছিল তখন আমাদের রেগুলার বেস স্টুডেন্ট খুব বেশি ছিল না ছিল আমাদের শুধু ডিপ্লোমা বেস তো 2-4 জন 5 জন করে আসতো কাজেই তারা ক্লাসও ঠিক মতো করতো না তাদের নিয়ে আমরা চিন্তাও করতে পারি না যে এরকম কোনো প্রজেক্ট তো ওরা শুধুমাত্র আসতো পাস করে সার্টিফিকেট নেওয়ার জন্য আসতো তো এখন এখানে আসার পরে তোমরা 9 ব্যাচ
স্যার 10 ব্যাচ 11 ব্যাচ
10 ব্যাচ এবং 11 ব্যাচ এরা এসে এবং একই সাথে আমরা এই কয়েকজন স্যার এবং ম্যাডাম ডাইনামিক পেয়েছি যাতে এই যে কম্বিনেশন তোমাদের যে মানে বলবো যে তোমাদের যে মানে চেষ্টা এবং যে তোমাদের যে এই করছো আর অন্যদিকে স্যারদের ইন্সপিরেশন এবং এই দুইটা আমাদের মধ্যে একটা টিউন হয়ে গেছে যার কারণে অল্প সময়েই আমাদের এই ত্রিপুরা বিশেষ করে তোমাদের এই প্রজেক্টের মাধ্যমে আমরা তো বাইরে সাহেব আমরা দুইটা মানে বড় এই কম্পিটিশন আমরা উইন করেছি তো এটা আমাদের জন্য খুবই ইন্সপিরেশন এবং আমাদের ইউনিভার্সিটির জন্য এবং আমাদের এই ত্রিপুরা ডিপার্টমেন্টটা কিন্তু অন্য ডিপার্টমেন্টগুলি আমাদের ছিল কি বিভিন্নভাবে বিজনেস বা সিএসি মানে বাই দিস টাইম কিন্তু তারা বেশি ডেভেলপ এবং হয়ে গেছে কিন্তু ত্রিপুরা ডিপার্টমেন্ট মনে হয় যে ত্রিপুরা ডিপার্টমেন্টে আমরা আগাইতে পারতেছিলাম না কিছু ড্রব্যাক আমাদের বা মানে পরিস্থিতিরাও তখন আসতেছিল না যে তোমাদের এই যে রিসেন্ট যে আমাদের যে অ্যাচিভমেন্টগুলি হয়েছে, এই অ্যাচিভমেন্টের মাধ্যমে আমরা কিন্তু এখন এমন এক এই ডিপার্টমেন্ট এমন এক জায়গায় পৌঁছেছে, এটা কিন্তু সব অন্যান্য ভালো ভালো ইউনিভার্সিটিকে কম্পিট করার মতো অবস্থায়। তো আমি আশা করবো, এবং তোমাদের আজকের প্রেজেন্টেশন আমি শেষ আসলে সত্যি দেখলাম আর কি, ফ্যান্টাস্টিক। তো আশা করবো যে আমরা তোমাদের এই পারফরমেন্স যেটা অব্যাহত থাকবে, এবং নেক্সট তারা আমাদের 13 ব্যাচে আসবে, তারা তো নিশ্চয়ই এগুলি জেনেই বা রিসেন্ট যারা ভর্তি হবে তারা জেনেই গেছে যে ইউনিভার্সিটি স্কলারশিপ ট্রিপল ডিপার্টমেন্ট কী করছে। তো আশা করবো ইনশাল্লাহ আমরা ফার্দার মানে গ্রাজুয়ালি আমরা আরও ভালোর দিকে আমাদের এই ট্রিপল ডিপার্টমেন্ট এক সময় একদম সবার কাছে একদম হয়ে থাকবা হবে এরকম যে ইউনিভার্সিটি স্কলারশিপ ট্রিপল ডিপার্টমেন্ট খুবই ভালো, এখানে সেই পড়াশোনা ভালো হয় এবং প্রজেক্ট এবং মানে ইনোভেশন টাইপের কাজ যেগুলি হয় সেগুলি ইন্সপায়ারিং। তবে থ্যাংক ইউ ভেরি মাচ।